Hello everybody and welcome to Glow Your Own. It's Tuesday, 5 o'clock. It's the second session and it's really cool to have so many people back. As usual, we've got Sarah doing some troubleshooting, CJ, who's our artist, helping with the creative aspect, and we've got Sophie, who's doing the coding, and Sophie's brought her colleague Laura. So maybe Laura, if you'd like to unmute yourself and just say hello to everyone because we've not met you before.
Hi, I'm Laura. I work at the Rutherford Appleton laboratory with Sophie, and I work in the scientific computing department. My work is all about making programs so that scientists can look at X-ray images, and I'm going to be helping with your coding today.
Great. So a real need as to how to control X-rays, and you can use all sorts of computer coding for that. So some of the skills you'll pick up today and throughout Glow Your Own might end up in a job in this big building behind Laura or behind Sophie one day in the future. Okay, so we've got a lot to get through today. So Sophie, shall we get cracking?
Absolutely. And yes, today we're over the next 6 weeks, we're doing stuff for creating our beautiful Christmas lanterns, but the same code that we're using to do that is actually used at the lab that Laura and I work in all of our experiments and to try and understand it. So they're really good skills to learn. So what we're going to do today, last time we had a light and it was great and it turned on and that was fantastic, but that wouldn't be the most exciting Christmas lantern. So we're going to start to have multiple lights and to start to flash them. So if you could all head to Tinkercad. So this is my Tinkercad. We're going to create a new circuit. All right, I think a fair few people are onto Tinkercad. So we're going to create a new circuit and get started. So you click create new circuit and then you're here. So the way we're going to do this is we'll do a couple of the steps to build our circuit on Tinkercad. And then CJ will take you through doing it in real life as well. So we can build each part together as we go along. So the first thing we need to do is get our Arduino. And you'll remember that they are here over at the side. I don't know, it was very excited about having a new microbit, but we want an Arduino. So we can pull that over here and bring it up like this. Okay. And then we also want a breadboard. So I'm going to bring my breadboard over and do it that. And now you'll remember how breadboard works. They just make our lives a lot easier, especially when we're doing it in real life, because there are these secret connections under here. So all of the things with a green circle around, they're all connected underneath the plastic. And that makes it much easier because it means you don't have to tie wires together or do soldering, melt them together. And if you're as terrible at me at that kind of thing, you're very grateful for breadboards. All right, so we're going to start with the circuit that we created last time. So a light, an LED, a light that turns on. So I'm going to bring out my LED and I'm going to pop it on one side of the board. Like this. Okay, so bring that over. I'm going to do another couple of bits of the code, and sorry, not bits of the code, bits of the circuit, and then I'll hand over to CJ so that we can build the physical circuit with them. All right, so once you've got your LED, the next thing we want is to connect our LED to our Arduino. Okay. So we're going to connect it to pin 10 here. So you can remember all of these pins are numbered. And to create a wire, we just go from here all the way up to here. So it's connected to the same column as this leg of the LED. And CJ will explain that we've got to be careful which way round we put our LED in, because it only works one way, won't you?
Yep.
Fantastic. All right. So
go now, yeah. Should
I
do the physical?
Yeah, do you want to show us now?
Yeah. Okay. So bear with me. Can you see this? Is that
Yep.
visible? Yep.
I'm just going to make you big for everyone, spotlight for everyone. So
Okay.
yes, CJ might have just got big on your screen so you can see their circuit.
Okay, cool. So I've got my breadboard here and my individual components. But first of all, we've got our LED, which is what Sophie was just talking about. If we place this with the left, so we're going to have the long leg into. I'm going to call out the coordinates, but obviously, if you don't remember now, you can listen to the recording afterwards. And we're going to put the longer leg, that's the positive, into D2, and then the shorter leg is going to go. That's the negative side. It's going to go into D4. So that's in now in D2 and D4. Make sure that the positive leg is in D2 and the negative is in D4, because the reason this is this way is because we line up the positive side with the resistor and the connecting wire that goes into the Arduino. It all has to be in line with positive and negative. So that's the LED in. Do you want to go back to Sophie to continue?
I'll just let everyone have a look at your at your circuit just for a minute so you can see it in real life.
So you can ignore the other ones, but this is just the LED in D2 and D4.
If you want to give us a wave, if you've got your Tinkercad circuit up, and if you're doing your real circuit, have it with your real circuit as well. Not yet, that's absolutely fine. We won't go too fast, everyone. Brilliant. I can see some more people having their Meerkat waves. Fantastic.
So the positive, the long leg's in D2 and short leg is in D4.
Yep. That's because LEDs are very special and they only let the electricity flow one way through them. So you've got to make sure it's the right way around. I think that we had a fair few people waving, so I'm going to share my screen again. And we'll do the next couple of bits. Okay, so 2 more bits, and then we've got 1 complete circuit, and then we're going to do a whole other one. All right, so you'll remember that the thing that we wanted, the next thing we needed was the resistor. Remember we did this last time. So you click the resistor and pull it out. You want to put it next to the other leg of the LED and connect it to the, all the way down here to this one that is next to the minus sign, or the blue one, okay? And this is quite a big resistor. So we want to change the value of the resistor. You'll remember that resistors reduce the amount of current of energy that our LED has, so it's not too bright. So we want to change that from 1 kilo ohm, so that's 1,000, down to 220. And you can change this to an ohm like that. Okay, so you can change that value up here. And then one last thing to make a complete circuit, because at the moment you'll remember I was very excited about complete circuits last time, Laura. You have to go, the electricity has to be able to travel on a complete path. And at the moment it goes from the Arduino up through the wire, through the LED, down through the resistor, and then it has nowhere to go. So we need to create that last bit. So we want to have another wire that goes from this minus line. You can see it's highlighted in green, back to the Arduino, to the one that says ground or GND, like that. And I'm going to change the color of my wire to be brown, like this. And now I've got a complete circuit. Okay, I'll leave that up just for a minute. If you've got that on Tinkercad, get ready with another wire and have a look at your resistors. So I'll leave it up so you can see the pattern. And then CJ will show you on their circuit.
And on my circuit, my resistors are not going in exactly the same way as you, but I think it still exactly works the same way. It's just the completion of a circuit. So I think it works easier when you're adding in more sensors to put the resistors in higher up, if that makes sense. But I'll just explain. So we've got our resistor here, the 220 ohms resistor, which is generally the standard 220 ohm that we use, particularly for LEDs because of the amount of resistance. So if we put one leg, that doesn't matter with these legs because they're exactly the same size, one leg into C1 and the other leg needs to go into, they're a bit fiddly, into D2. And this is important here that it's lined up with the long leg of the LED. So that's why it's going below it, next to it. So the long LED is in D2 and this one's going into C2. So the other end of the resistor, important to be next to that longer leg there, the positive side. And then in the same way that Sophie has connected up this side, we get one jumper wire. If you've got one of any color, this is going to be used for our pins on the Arduino. We take one end and we put it into B1. That's in line with the left leg of the resistor. And the other one is going into pin, what pin did you use, Sophie?
The ground pin.
No, for the positive, for the pin for like pin 10 or 11.
Oh, pin 10.
Pin 10, yeah. So we're going to put that into pin 10, and then to connect up our ground, we go to the minus strip on the breadboard, and then the other end is going into the ground pin on the Arduino board. Like so, it's not super visible, but it's the GND pin on the Arduino board, and that's going into the minus line on the breadboard.
Fab. So does everybody have their circuit on Tinkercad and in real life? If you've got there, give us a wave. If you're still working on it, or if you have any questions, do pop them in the chat. Raul has got there, fantastic. You can see that some of you have your circuits. The resistor, so I'm just going to share my screen again so that you can all see clearly how it's all meant to be connected. So a good idea whenever you're making a circuit is to trace the path of the electricity. So the resistor goes from the long leg of the LED, of the light. So it goes from there all the way down to our minus line, like that. And the bulb, the LED, I always think of them as light bulbs too. They go up here.
We've got one more wire to add in though for the physical, just to make sure that we are fully connected to our ground pin. So shall I just quickly say the coordinates for that? Yeah. So we go one end into the minus line, and then we have to connect up the shorter end of the LED. So we're going to put the other end of that ground wire into C4. So that way all the circuit is now complete and flowing all around.
All right, thank you, CJ. So this is the circuit that we made last time. The difference is that we've done it in real life as well this time. All right. Okay, so we want to make another, so this is great. We've got a lovely circuit, but I think that we want to make it a bit more exciting than last time. So we are going to add another LED, which is pretty cool. So I'm going to grab another LED and pull it out and just pop it over next to the first one. But I don't want two red LEDs. I'm going to have a red LED and a green one. You can change whichever color you want. You can pick whichever colors of LED you want. But I'm going to go for red and green because that seems like a nice color combination to me. And so we're just going to create another circuit with this, this LED. So we need another resistor, just like this one. So we're going to pull this out and bring it over to the left-hand side on this. But remember, we need to change the resistance rather, to 220 ohms. Do make sure that you change this one on this, because otherwise it's going to be a really, really big resistor and the poor LED might not get enough light, enough energy to turn on properly. And that's actually something that I often get wrong when I'm making a physical circuit with my Arduino. I pick up the wrong resistor and use the wrong one. But that's fairly easy because you can just change it. You can see on the resistors, they often have these little paper strips and it tells you what value of the resistor it is on there. All right, I'm going to add one more wire before handing back to CJ to make the real, the physical circuit. Now, you'll see that this isn't quite the same as this wire, is it? As this circuit, is it? So we want to connect the LED to a different pin on the Arduino so that we can control it and send it instructions. So I'm going to create another wire that goes from the other leg of the LED all the way down to pin 11. Oh, like that. And I'm going to make that wire green as well, just so that it matches. And now you see that this is a complete circuit too, because if you track the path of the electricity, it goes on up here to the Arduino, up through pin 11, along the wire, tracing along to the LED, through the resistor, and then it's back on this ground wire. And so it can go back down this wire here, all the way back to the Arduino. So you can see we've got that complete circuit. So CJ is going to make that next bit of it, and then we're going to have two circuits and we're going to make them flash, or at least that's the plan. Okay, CJ, you ready to do the next bit?
Yep. Okay, so we take our other LED and we've got the longer leg into D9 and the shorter leg in D11. You can use these coordinates if you want. It's just to kind of go through now or later when you're doing the physical setup at home, but both Sophie's and mine circuits work in exactly the same way. It's just slightly different setup, but they're exactly the same amount of electricity and everything like this. Okay, so that's our LED in. The longer leg is in D9 and the shorter leg is in D11. Then we'll get our resistor. Again, it's the 220 ohms because we're just repeating the original one that we just did there with the other LED. We're going to put one end of the resistor into, what have we got? C9. I think that's right. Yeah, one end into C9 and one into C7. Quite long. C9 and C7. So one end of the resistor should line up with the left long leg of the LED, and the other one is just to the left of it. And you'll see lots of variations of how this setup is done, but as long as the circuit is complete and in the correct order, we're all good. So our resistor's in there. Now we need to take another jumper wire, so another color if you want, so we can distinguish between LEDs. Then we're going to put one end into B7, and we're going to put the other end of that into our pin on the breadboard. So we're going to use 11. So that's our positive side set up. And then we finally get our ground wire. And because we already have the ground connected up onto the breadboard here, all we need to do is take one end of the black wires and put it to the shorter end of the LED. So that would be C11, because our short leg is in D11. So we're going to go below that into C11 for our negative, for our ground. And the other end, we're going to place into the minus strip on the breadboard. And then because we have, again, our other black wire that's going to the ground on the board, it will all connect up, and that's the complete circuit.
All right, I will pop the shared screen up for a second so that you can all carry on working on that and see where all of the wires and everything can go. And I think, Jakob, there are somebody asked a question about all of the different things that you could see on the right-hand side. That is the right-hand side, right? Yes. So these are all of the different components that you can use to create our pretend circuits, our simulated circuits. And so we can use things like the batteries, and we can put a battery in and see what would work, what would happen if we put a battery into a particular place in the circuit. We could try all kinds of different things using these things, and do have an explore. There are lots of different things that you can do on Tinkercad, not just the stuff that we are doing. All right, is everyone ready to have a go at coding this? Give me a wave, like put a reaction up if you are ready for us to do the coding. You'll still be able to see the circuit while we're doing the coding. Fantastic, we've got some ticks, some thumbs up, brilliant. Good job, everybody. More thumbs up. A cat. Do you like the cat one? As a reaction. Sensible to do it as a reaction, not in the chat, please. Fab. All right. Now you will remember, I am sure, how we write our code. And don't forget that this is all recorded, so you can go back and watch this and do it step by step. Pause me, mute me if you want. I'm sure there are people that would like to mute me in real life. So we want to go up here to the code. We click this button, and then our beautiful set of commands, instructions that we can send to our Arduino come up. Now it comes up with this automatically, but we don't want that. So I'm going to pop that down here into the rubbish bin. I'm just going to get rid of it like that. And what we want to do with our code is, what I want to do is we're going to first turn the red light on, and then as the red light turns off, I'm going to turn the green light on, and then the green light's going to turn off and the red light's going to turn on. So I want to have a lovely loop that has them flashing alternately, red, then green, then red, then green, because that's a bit like a Christmas tree light, right? And I think that would be a cool thing for us to be able to do. So you'll remember that last time we used these controls, these orange things, and we use this one called repeat while. So if you just go to control and then drag repeat while over here, we're going to repeat everything that's in, we're going to get the Arduino to repeat all of the instructions that are inside this little block here while something is true. And the thing that we're going to make true is some maths. If you go to maths, and then you've got these different triangle-y things. They're not triangles anyway, are they? You pull this one out that says the 1 and then an arrow and 1. We pop that in here. And we change this, instead of 1 being less than, that's what this arrow means, to being 1 that is equal than. And Tinkercad's really good because it will show you all of the different options. So every command that we put in here is going to be repeated as long as 1 equals 1, which hopefully is forever, because otherwise all of my maths will be wrong. Okay. And then we want to turn the circuit. We want to turn the LED connected to pin 10, so my red one here, on. Can anyone remember, pop your hand up if you remember how we turn that LED on? Which bit do I put in? Carl remembers, fantastic. Brilliant. Bunch of people remember, fab. So we are going to go to the output function because we want to send a message out to our LED. We want to go to the output and we want to turn the LED connected to pin 10 on. So we get this, set pin 10, set pin to high. We're going to pop that in there. And instead of pin 0, nothing's connected to pin 0. That wouldn't do anything. We want to change that to pin 10. Okay. At the same time, we want the other LED that's connected to pin 11 to be turned off. So we're going to use the same command, but remember to change this to pin 11 and to change this from high, on, or 1 to low, which is the same as off. Give me a wave when you're there, and we will do the next steps. Brilliant. Some of you are already there. Fantastic. Got some waves and some ticks. Fab. All right. Now you'll remember that we talked about we needed to put some pauses into our code because the computer's much faster than our eyes can catch up. So we're now going to have a little pause. We're going to have the lights turn on. So we're going to go to control and tick the wait. We're going to wait for a certain number of seconds and pop that in here. And I'm going to wait for half a second. I think I want my lights to flash pretty quickly, but you can pick however many seconds you want there to change that. And then after that, after my red LED has been on and my green has been off, I want to change it round. So I'm going to send new commands to those pins, to those LEDs. Set pin, I want my red one to go off. So that's the one connected to pin 10, remember? 10 to go off, but that says 10 to go on. So 10 to go to low. And I want the other one to go on. Set pin 10, set pin 11 to be high. Now, it doesn't actually matter what pin numbers you pick. All of these digital ones will send instructions, but what you do need to remember is you need to make sure that the instructions are going to the right pin that's connected to the thing that you want to. So if I had said set pin 4 to high, it would just send an instruction to this pin, but that pin's not connected to anything, so it wouldn't do anything. So you just need to make sure that they match. That's the important thing. And the final thing before we test our code, remember that's really important, is we want to go to control and we want to wait for another half a second or however many seconds you want. I'm going to pop that in here and have a wait. Oh, went wrong. Wait for half a second. Okay. Now, give me a wave when you are ready to test your circuit, to test it on Tinkercad. Now, we're going to test it on Tinkercad first. Oh, brilliant, loads of you, because that way we'll know if it works on Tinkercad, then we know that our code is right and our code will do the right thing. So then when we test it on the real thing, if it doesn't work, we know that there's something wrong with the circuit, which if you're me, there often is. All right, so we've got a bunch of people ready to get started. And so you'll remember we need to go up to here to start simulation, cross your fingers and press start simulation. Right, so my red light, oh, my green light, red and green, red, green, red, green, red, green. So you see my light is working, Lincoln's is working too. Fantastic, good job, Lincoln. Hooray, we've got lots of people working, fantastic. We've got Tinkercad working, but are struggling with the real world. Fab. So it is always a bit tricky to start with when you're creating the real circuits. It does take a bit of time, so don't worry at all if you haven't quite got there, because what you can do afterwards, you can watch the video. You can also just come back, because you can go back and look at your code, look at your Tinkercad, and you can create the circuit from looking at your Tinkercad or from the instructions that we sent to you. Brilliant. We've got loads of people's working. Honestly, you're so fantastic, everybody. Other helpers, Laura's yours working too. Laura's is working, hurrah.
It is working.
Sarah's working, Dane's is working. Fantastic. We've got lots of people's working. All right. So now we're going to send it to our physical Arduino, to our real one. We need to have some software on our computers to be able to send the code to the physical Arduinos, and you might not have got there. It was in the document that we got sent, that everyone got sent, so you can spot that, and you can find the you can download the software if it's not there by going to this web address, which I've just popped in the chat. Fab. Okay, so once you install that, and you can do that just by looking at this web address and then software, and then you just download your code for Windows normally, or if you've got a Mac, you can use Mac. If you've got Linux, then that's awesome. I love Linux. You can use that instead. Okay, and you just follow that like you'd install anything else. You open something that looks a bit like this. All right. Now, the way we talk to computers is called a coding language. And there are lots and lots of different coding languages. I like Tinkercad, but I think, CJ, you prefer using words, don't you, to Tinkercad?
Yes. Well, the physical, yes. I do.
Yes.
Yeah.
Yeah. So there are lots of different ways of doing it, and that's absolutely fine. Everyone has a different favorite thing. But what's nice about Tinkercad is that we can change our nice blocks to something that we can put straight into our Arduino. Okay, I'm just going to stop my simulation. And you can see over here, there's this thing called blocks. All right. If you click on that, there are some options. If you change it to blocks plus text, then you see your code written in these blocks that we used, but you can also see it in this different language, in words, and it's a language called C++. It's used in lots and lots of different things. I bet Laura uses it a lot in her work. It's not my favorite, but it's pretty okay. And all we need to do to transfer it to transfer it to our physical Arduino is we need to highlight this, and then copy it. So Control-C, or you can right-click and press copy. Okay, and then you go to your Arduino software, this one, and you delete everything that was in there, and then you just paste it in like that, so you can see it in there. And then you save it, because it's always a good idea to save your code. So I'm going to save it as, I'm going to call it, what am I going to call it? I'm going to call it Glow Your Own 2, like that. Okay, so you see now it's called Glow Your Own 2. Now we have to get these instructions. These instructions are in a nice format that our Arduino can understand. So we have to get them from our computer to our Arduino. So what we're going to do is there should be a cable, a USB cable with your Arduino. It's a bit like this. You plug one end of it into your computer, the USB slot, and the second into your Arduino. I've lost all of my hands. There we go. You can see one bit of the Arduino has a nice USB type place. You just plug that in. You remember, oh, Dana's doing it. Fab. You remember that last time I said we said it was really, really important not to change any components when your Arduino is powered in. And that's still really important. Now that it's plugged into the computer, we don't change any of them, do we, CJ?
No, just leave them as they are. Yeah.
Yep. If we want to change any of them, we unplug it first. Very important.
Otherwise you can blow the sensors.
Yes, sometimes it causes them to break. And if you were, so this is a little baby circuit, but if you were doing it with a big circuit, like the kind of computers that Laura works with, the big supercomputers, then you could hurt yourself if you were doing it with a big circuit. That's why you always unplug it first. All right. And then it's really easy to send your code to your Arduino because you just get this little, you see there's a little thing here with an arrow. If you highlight it, if you hover over it, it says upload, you click on that. Now remember, all of these instructions are in the PDF that we sent out. So don't worry if we're going a bit too fast. You click upload, and then down here it says compiling sketch. That's computer speak for I'm thinking about it. You've asked me to do something really hard, so I've got to think a bit. You can see it's still thinking, still thinking. Now it's actually sending it. It says it's done uploading. And so if you've done your circuit right, then you will you'll have flashing lights. Now, who wants to bet if my lights are flashing or not? All right. Awesome. Laura's worked. CJ's is working. That does not surprise me, CJ, because you're really good at this bit. I'm quite surprised. I normally get them the wrong way around. Dane's is working. Fantastic. Do we have, oh, we've got a flashing Arduino from Isabel. Brilliant. My lights are flashing really quite brightly, so I'm going to turn it off because I'm going to get blinded. Clearly, I should have used a bigger resistor. So we've got some fantastic people working. Fantastic. It works. Love it in capital letters. Brilliant. So some of you it's working first time. That's amazing. The first time I made this when I was practicing, it definitely did not work. I had to unplug it, check my connections. So if it isn't working, pop something in the chat and we will do our best to help you.
And also the port, do we check through that their ports connected up? Should I share my screen?
Yeah, hang on.
Okay, so everybody see that? So if for any reason it's not uploading to the board, it might have an error message at the bottom that says, I think it's something can't upload. It might be because we haven't selected the Arduino board on our port. So if we go here to tools, we have to check these two words here. So board, you need to make sure that's Arduino Uno. So the arrow across takes you down to make sure it's ticked like that. And then the second one is port. So if we click across, and we need to ensure that the Arduino or Uno, it's usually is it USB modem for most people? As long as in brackets it says Arduino Uno, that's selected as well. So Arduino Uno on the board, and then on the port as well, Arduino Uno. So that might be a reason if anybody is struggling with uploading it to the board. Okay.
Yeah, that is the most common error that we get. And I think it's just because the computer gets confused about which USB port it's meant to be sending the instructions to. Poor little computer can't cope. And so you just have to be, no, definitely this one, computer, you can do it. I am so impressed with the number of people that worked, aren't you, CJ? It's fantastic.
Yeah, it's great. There's a lot of people on here as well. It's good.
Yeah.
I have a small confession to make. So mine didn't work first time round, but it was because I put my LEDs in the wrong way around. So I quickly thought, I'm just going to take them out, swap because what you may have seen is that the LEDs have 2 different length legs. So I'm just going to hold it up here. Hopefully you can see it. So the legs are slightly different lengths. Don't know if you can see that. It's not much in it, but they're slightly different. And so if you've got the LED in the wrong way round, if you just take it out, spin it round and put it back in the same 2 holes, that might be a fix.
Yeah. That's a good.
I did the exact same thing, Dane. And both of mine were the wrong way around.
So we all make little mistakes every now and again, but they're usually quite straightforward to fix. And if they're not straightforward to fix, they're quite interesting.
Yeah, absolutely. It's always exciting when you get a different error that you've never seen before in your code. I love that bit because it means you get to learn something new. Fab. I'm so impressed with the number of people that has worked straight away, because I had to practice a couple of times to do it right. So what we're going to do now is I'm going to hand over to CJ. Sarah and Laura and I and Dane will keep looking at the chat to see if we can help out with different problems. And CJ is going to start us all thinking about how we can use this cool stuff to create our art, our lanterns at the end of it. Right, CJ?
Yep. Great. So I'm going to get you to do an activity now, which would be great if you could do it now, or you can do it afterwards in your own time. But I'll set it out for you now. It's a bit of kind of like a little mini story, I suppose, and an imagination game to get us thinking. So I want you to think about the idea of darkness, and this can be darkness in the physical sense. So like a night sky, a nighttime, could be a dark room, a tunnel, or the bottom of the sea, or even under the ground beneath the soil. Anywhere that you think maybe is a dark place. Could be emotionally as well for some, but physically is probably the kind of go-to imagination kind of setting. So now, once you've found, I'll give you, let's say 10 seconds to think of a place. You can change this as well, but just for now, let's, because we haven't got loads of time. So have just to think about that. A dark place. Okay, so now I want you to imagine that you're in this place. So if you can take your imagination there, and what would be the one thing that could bring some light to you when you're in this place? So here we could think about things like stars, for example. If we're in a really dark, it could be those light up stars that we have in our room, or fairy lights, a rocket, fireflies, for instance, or a candle or a torch. Also things under the sea also glow in the dark, so some of the sea creatures can glow in the dark as well. So have a think about anything that you might want in this dark place to bring you some light. And also it could be made up. You could hybrid any one of these things. So you could combine them. You could make up your own magical creature or own kind of piece of technology that would bring you light. You can be as creative as you want. So have a little think about that now. And if I'm going to ask you if you could possibly draw it out onto a piece of paper and either share it with us now or the next session, or just do it in your own time, and you don't have to share it, but just to get us thinking, because this is going to build the blocks really for the lanterns that we're going to create towards the end with our LEDs flashing inside. So have a think now. It'd be nice if you would do a little drawing now, if you have got a pen and paper handy. I'm going to do a little drawing and then I'll show you mine. So I'll give you just a few moments to do that. Doesn't have to be picture perfect, really artistic design, just a little sketch of what might be the thing that brings light to you in these dark places. I'll show you mine. I've got a glowworm. Is that back to front? The words. Can you see?
No, it's fine. We can
Okay,
read
yeah,
it.
that's cool. I've got a little glowworm friend. Ah, yes. We've got what are those fishes called again?
Anglerfish.
Anglerfish. Thank you. That's awesome. Thanks, Laura. Anybody else would like to share? Feel free. Oh, nice. Dane's done a really cool candle. That's wicked. Good work. As I said, you don't have to share, but if just to get you thinking in the coming weeks of different sort of things that you might want to create when we do our mini sculptures. So yeah, that's it from me, I think.
Can I share mine?
Yeah.
Yeah.
Oh,
This is totally cheating because it's something that somebody literally just sent to me, but it's all about shining light into the dark. So it made me really happy.
yeah, that's brilliant. Thank you. That's a good torch. That's like a really bright torch. There's
Absolutely.
Great. Well, dark matter's even more complicated than LEDs. No,
it's not, Dane. No, it's not.
Okay.
Just
All right.
heavy. That's all. Heavy stuff that we can't touch.
I've got one from Shihan. That's nice. Hold it a bit closer.
Brilliant.
Oh, very cool. That is some sort of interesting light form in somebody's hand. That's wicked. Well done, Shihan.
Right. Well, CJ, thanks for that. It's good to think about the darkness, and Sophie, it's good to think about dark matter as well. And it's maybe we'll explore that one day if it's not too difficult to do.
No, definitely not.
So I think that's probably it. We've got most of our LEDs flashing. We've got the bit at the end, so we've got about half an hour of troubleshooting. So if you've had a problem getting your LEDs to flash properly as you want them to be, you can stay behind and we'll turn off the recording and we'll have a little go at trying to fix it to make it work for you. But I'm super happy that so many people got their LEDs flashing, going tick tock, flash, 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 flash. That was cool. So thanks so much, Sophie, for doing that. Thanks, CJ, for getting us all thinking about darkness and lightness and where these LED Arduinos might take us over the next few weeks. Thanks all for joining in, and Sarah for the troubleshooting. It's brilliant. I'm so happy that everyone's making really good progress. If you want to stay behind, please do. But otherwise, we will see you next time. Have a nice evening, everybody. Bye-bye.
Well done, everyone.
Thanks, everybody. Bye-bye.